Hello, today I am going to discuss chain reaction. Okay, I have already explained to you fission, nuclear fission. Okay, chain reaction is what? The nuclear fission which once started continues till all the atoms of the fissionable material are disintegrated is known as chain reaction. Okay, here you see the diagram. When one neutrons will go on with uranium. Okay, reaction will occur with uranium. Then what will happen? 3 neutrons are released. Okay, after this again with one neutron, suppose 1 neutron go with uranium, again 3 neutrons were released. Again second neutron, if it will go with another uranium, then again 3 neutrons were released. This third one also with 1 uranium, when it will reaction will occur, then again 3 neutrons are released. Like this, 3 total 9 neutrons are released. So this way this process is going on. Okay, again another neutron, this neutron will again it will another uranium will reaction will occur, then again 3 neutrons will be released. So like this process is going on, that's why it is called chain reaction. Okay, here this one term is we are using, this is called neutron multiplication factor or reproduction factor. Okay, this is the formula for what we see now. Neutron multiplication factor k equal to what? Rate of production of neutrons by rate of loss of neutrons. Okay, now what is this for chain reaction? The value of k should be this k, we are denoting by k multiplication factor. This value of k should be greater than 1. Okay, the value of k greater than 1 means the neutrons increase or multiply with time. Okay, k is called neutron multiplication factor or reproduction factor. This is important. What is this k? Okay, now how many types of chain reaction are there? There are 2 types of chain reaction. What are those? Explosive chain reaction, this is we can say also uncontrolled chain reaction and another is controlled chain reaction. Okay, now we'll discuss 2 types. Okay, explosive chain reaction. What is explosive chain reaction? A nuclear chain reaction in which fission neutrons keep on increasing till whole of the fissionable material is consumed or disintegrated. Okay, is known as explosive chain reaction. In explosive chain reaction, there is one thing you should remember, that if the mass of the fissionable material is should be more than a certain mass called critical mass. Okay, if the mass of the fissionable material is more than a certain mass called critical mass. Okay, if that one in the explosive chain reaction, mass of the fissionable material is more than, then this mass is called critical mass. Okay, if mass of the fissionable material is small, then chances of fission neutrons to cause further fission are small because they may escape without causing any fusion. Okay, the mass of the fissionable material is increased, there are more atoms in the way of fission neutron, and hence the probability of the further fission is increased. Therefore, that in order to cause explosive chain reaction, mass of the fissionable material must be equal or more than a critical mass. Okay, this is very important. Okay, now conditions for explosive chain reaction. In order to produce explosive chain reaction, the following conditions must be fulfilled. What are those 2 conditions are there? Mass and size of the fissionable material must not be less than the critical values called critical mass and critical size. That means it should be more than that. Okay, it is because below these values the neutrons produced during fission will escape out of the material, hence the chain reaction will not take place. Okay, that means it should be more than the critical mass. Fissionable material is more than a critical mass. Okay, number 2, the fissionable material must be in the pure form. It is because if an impurity like 92 uranium 92 and 238 if present in uranium 92 to 35, the secondary neutrons produced would be captured by it and the chain reaction would stop. Okay, so impurity should not be there. It should be pure form. Okay, these 2 conditions are there. Okay, that means fissionable material should be more than a critical mass, and another one is there that fissionable material should be pure form. Okay, now number 2 is what? Controlled chain reaction. This one, explosive chain reaction means uncontrolled, we cannot control, but controlled chain reaction can be controlled. Okay, what is this? See now, a chain reaction that proceeds slowly without any explosion and in which energy released can be controlled is known as controlled chain reaction. Okay, this chain reaction can be controlled by systematically removing some of the fission neutrons from the reaction vessel. Greater the number of fission neutrons removed, the lesser is the intensity, or you can say fission rate, that is of the energy released. Okay, now what is this? How will be controlled this control chain reaction? This control chain reaction can be controlled by the apparatus. This is called nuclear reactor. Okay, what is nuclear reactor? It may come. What is nuclear reactor? So the apparatus in which control chain reaction takes place. The apparatus in which control chain reaction takes place is called a nuclear reactor. We can control by this apparatus. Okay. It may be mentioned here that the control chain reaction is the basis of all peaceful uses of nuclear energy. Okay, so this is we have studied today about what chain reaction. Then diagram you should draw this one, chain reaction definition diagram. Then how many types of chain reaction we have seen? Two types, explosive chain reaction and controlled chain reaction. Explosive chain reaction definition you have to study. What is the condition to for what is the condition to we have to use for explosive chain reaction? There are two conditions, we have to see this. And what is control chain reaction? Control chain reaction definition. And then what is nuclear reactor? Okay, and then in chain reaction another one is there, the multiplication factor. What is the multiplication factor? This formula, what is the value of k should be greater than 1, we have seen. So today up to this much. Next class I will do nuclear fusion. Okay.